Hello guys, it's Johnny time and welcome to another decentralized finance tutorial. Today we have a special video. Today we are going to do a solution, a walkthrough on the PancakeSwap CTF Capture the Flag Easter egg challenge that was introduced by Chef Rabbit Doge from the team of PancakeSwap. This kind of Easter egg that the gift that they hid inside the PancakeSquad NFTs. So we're gonna go through the solution, how I solved it. I'm gonna share it with you, and hopefully you can learn something new about DeFi, about decentralized IPFS, decentralization, seed phrases, and much more. So this video is gonna be very educational. Watch it till the end to get the most amount of value of it. It's also fun, you're gonna enjoy it because I enjoyed solving the challenge and I'm enjoying right now making these videos for you. So make sure to watch it till the end to get the most of it. But before we start, make sure to subscribe to the channel and click the small bell notification button. And if you like my content, consider smashing that like button so YouTube algorithm will expose it to many more people that can learn about PancakeSwap, DeFi, and get more education. So let's get started. So last week, I think it was last week, there was this PancakeSquad NFT sale, 10,000 unique NFTs that has been sold for around $300 each. And I think 5 seconds or 10 seconds after the sale has been opened, all the NFTs were gone because everyone bought them and everyone was very excited. It was sold out after seconds. And then Chef Rabbit Doge here on Twitter right after said that someone told me there will be a surprise hidden in the Cake Squad. So what did you get? Reminder that there is a little secret discover and a reward for the first person who find it. So they left some kind of Easter egg, some kind of challenge, sometimes of gift inside one of the Pancake Squads, and this was crazy. When I saw it, I was excited because I like this kind of CTFs. My background is cybersecurity and I love what they are doing, and I was excited because I wanted to find this gift myself. So then I scrolled more and I was abroad. Meanwhile, I was in a cafe working on my computer, editing the videos. And then I see nobody found it and stopped spamming my DMs. And I said, all right, the race is still open. I'm gonna go for it and let's start. So my, before we start, I would want to say that I really enjoyed solving the challenge and I learned myself a lot. I learned more about IPFS and seed phrases, and I'm going to share everything that I did, all my thought process, how I went through and how I solved this challenge. So hopefully you can learn from this as well. And by the way, most of my channel is dedicated to PancakeSwap. I have so many educational PancakeSwap videos. I will put a link in the description below to other popular videos about PancakeSwap so you can watch them and learn as well. All right, so the first way that I thought about it is like, where can I find it? I have different places where I can look for the Easter egg. The first one was the website. So I went to the website and I went to the PancakeSwap website and I went to the PancakeSquad NFTs. I said maybe it might be in the source code, maybe it might be in the pictures themselves, in the description of the NFTs. And I went to the website and I tried to look for any clues, but I couldn't find anything. And I was not disappointed because I thought, all right, if it's not on the website, the next place when I might find a hint that made me get me closer into the answer and into the Easter egg would be the blockchain itself. Now I thought, all right, where would I go? The first places where I would go was the smart contracts of the NFTs. And there are two smart contracts, one that is responsible for the PancakeSwap NFTs, the PancakeSquad NFTs, that represents the NFTs themselves. And there was another smart contract that is responsible for the NFT sales. So I looked for the smart contracts. The smart contract for the NFTs can be found here. So this is the contract. I open it in a new tab. This is the smart contract from the NFTs. So it's responsible for the PancakeSwap NFTs. It's a contract, and you can see that it gets a lot of transactions all the time. It gets a lot of BEP20 tokens. I don't know why. These people by mistake sent some cake tokens to the smart contract. And the first thing I thought is maybe there should be something in the code itself. Maybe there is some kind of comment in the contract itself. So I went to the contract on bscscan, went to the code, and I copied everything, went to VS Code, my favorite text editor. By the way, you don't have to be technical, you don't have to need to code. I am a coder and I have this kind of advantage that I know a bit of Solidity, I know to automate stuff using Python, using JavaScript, but you don't have to be so in order to solve it. But for me, it was helpful. So I looked at the contract itself, and why is it annoying here? All right, so the contract, I changed it from JavaScript here to Solidity, so the syntax highlighting will be better. And here there are a lot of imports of other smart contracts, but the actual contracts, these are libraries or different smart contracts that the contracts use, but the actual smart contract will be on the bottom, which is here. PancakeSquad NFT, this is the Solidity ABI coder, PancakeSquad NFT collection, and you can see the contract name is PancakeSquad, and it has some variables, some declarations, some variables, and some events that it emits, and the functions. And I went through the functions and I couldn't find anything special, not in the comments nor in the functions themselves. These are legitimate, normal NFT functions, you know, to mint tokens, recover non-fungible tokens if someone sent by mistake an NFT token to this kind of contract, so it will be able to recover it, recover token, get base URI, get the URI for the data of every NFT. So these are legitimate, normal, very common NFT functions, and I couldn't find anything in a smart contract. Then I thought, all right, maybe it's not in the contract, but in the transaction. So the contract has been deployed here by this kind of address. And let's go to the first transaction. Maybe there was some kind of data that has been sent while the deployment or after the deployment. So I went here to the transactions and I went to the last page, and I see right here that the contract has been deployed around 3 days ago, and then there were some transaction, transfer ownership, safe transfer form, and approve, and all these kind of transactions are already transactions by users that approve the smart contract before the NFT sale. So it was nothing interesting for me, and that was a dead end. So I thought, all right, it's not in this kind of smart contract, I should look somewhere else. And actually there is another smart contract, the contract that's responsible for the sale, the contract responsible to take your cakes, give you a PancakeSquad ticket, and then later on when the third phrase is being started, to claim your NFTs. And this is actually the smart contract. The NFTSale is the one who can mint those PancakeSquad NFTs. So I said, how can I find the address of the PancakeSquad NFTSale smart contract? So I went to GitHub, PancakeSwap, and I don't know if you know, but the PancakeSwap is an open source project. Most of the code is open source. The website, the front end itself is open source, and in the website itself, there should be the contract address of the NFTSale contract because it needs to interact with the smart contract. So I went to PancakeSwap front end, and I went to SRC, and right here I went to it was under config. Under config there are constants and contracts. So this file contracts.ts holds all the smart contracts that the front-end website is interacting with, because it's a decentralized app that works with the blockchain. And I searched here for NFT, and I see Easter NFT. This is the old contract for the Easter NFT, NFT market, and NFTSale. This is the contract that I was looking for, and I copied the address. This is the address, and I copied it here to Binance Smart Chain and started looking at this contract. Unfortunately, when I went to the contract section, I see that the contract is not decoded. I could see only the binary, the opcodes of the contract, but not the code itself, because they did not made it an open source. They did not upload it and verified it with bscscan, and it does not exist in the GitHub as well. So I couldn't find anything interesting because this is gibberish, right? You need to do reverse engineering. This is too complicated, and I didn't think that they will make the Easter egg challenge so complicated because they want many people to be available, so it will be available for many people. So I went to the transaction, the same methodology that I did with the last contract, and I looked for the first transaction. Maybe I will find some kind of hint, and I see this is the contract creation 3 days ago, transferring ownership, set base URI, but there is no I didn't find anything interesting. Now I thought, all right, it's not in the website, it's not in the contract itself. Maybe it's in the data. maybe it's in the data itself of the PancakeSwap, maybe it's in the picture itself. So there is something called steganography, which means that you can hide data inside pictures. And maybe it's in the properties, or maybe it's here in the description, all right? So this would be my next thinking pattern, and I thought maybe it's somewhere there, but I said, how will I go through 10,000 pictures and extract the data from them? So there are different ways to do steganography. One way is just putting the text inside the image without damaging the image. Another way is maybe to change every single bit, every single pixel, last pixel, because I don't know if you know how colors are being presented on the screen, but there is a pixel that is being assembled from red, green, blue, because these three colors can assemble all the pictures, all the colors in the world. Red, green, blue. This is only what you need. So you have a range between 1 to 255 red, and then 1 to 255 green, and then 1 to 255 blue, because it's 8 bits. So if you change it from, let's say, from 103 red to 104, it will be just a different type of red, but very, very similar, so you would not notice any change in the picture. So that way you can use some kind of mathematical function called XOR, and then you can go every pixel and hide your data by XORing your data and the pixel. So this is also advanced way of steganography, and I didn't think that PancakeSwap team will go that far. So I said maybe it's somewhere hidden in the pictures, but I didn't know how would I go through 10,000 pictures and find for it. Also, I didn't know how I would go through all the properties, so I had to find a better way. And the answer would be IPFS. IPFS, I don't know if you know what it is. I will do a short explanation, but it's like a big subject. I'm not going to talk about it in this video. Maybe I will have another video dedicated to IPFS, but it's basically a decentralized way of storing data, storing files, storing JSON files, storing pictures, data which is static and not being changed. Like you have file servers, it's very, very similar to torrents. So it's like decentralized, it cannot be removed, and you can upload data and download data. You can download something called IPFS node. So this is right now an IPFS node. Now I'm connected to other peers and I can download and upload this kind of decentralized data. But don't worry, you don't need to have an IPFS node in order to access IPFS content. And I know that all the data here, usually NFT data are being stored on IPFS because it's decentralized, it cannot be censored, cannot be removed, and this is how we do it. So if you scroll down here, you can see that every PancakeSquad has this kind of URL, IPFS JSON. But if you click at it right here, it would not be open. Now it offers me to open my IPFS desktop app, but if it's not installed, then it will not be open, because as you can see here, it's a different protocol. It's an IPFS protocol and it's not HTTPS. So it needs this kind of, to connect to this kind of local IPFS node in order to present the data. So if you don't want to install an IPFS node, so you can search in Google how to open IPFS links. And you have some kind of centralized services that actually has the node from you, and they provide for you an HTTPS service to access the same actual resource. So instead of doing IPFS // you basically change the URL to this one, and then you can use an HTTPS protocol. So that's what I did, and I accessed the JSON file of the PancakeSquad NFT, just an example one to see how it looks like, all right? So this is the JSON, and again, this is JSON data, this is JavaScript object data, that's how it looks like, and I copy it to my VS Code always to make it more visible. So I'm beautifying it using a beautifier on VS Code, and it's already changed to JSON, and you can see what kind of data every PancakeSquad NFT has. So the first thing is the ID. Every NFT has a unique ID, a name, of course, a description. So this is the description that you can see right here. 10,000 unique randomly generated PancakeSwap NFTs from the mind of Chef Mid. Join the squad. This is the description that you can find right here. So all the data is being taken from the JSON and integrated into the website. These are the attributes of the PancakeSquad, the NFTs, and these are the same attributes that you can see right here. Yellow, polka pink, mom jeans, yellow, polka pink, etc., etc. And of course the image, a URL that redirects to the image. So you can copy this URL, open it, and of course change the prefix to this kind of IPFS. And there you go. You've got the image. One moment it will load it. It's quite slow, but eventually you're supposed to see the image itself right here. So this is the image. All right. So this is IPFS. This is how it works, and it's super cool. And now I said, oh my God, how I'm gonna go through 10,000 pictures and 10,000 JSON files. And thanks God, I'm a programmer, and that's why I made this kind of script. I made a Python script that automatically goes through all the JSON files. You can see right here. So this is the URL, the same URL that we just opened, and I saw that actually in the URL, the only thing that is being changed is this number. So if I change it to number 73, I will get the next JSON of the next NFT, same as the pictures right here. So this is the convention for every single data, every single resource. So I made this kind of short script to scrape using a request module called request in Python, and I downloaded all the NFTs data, all the JSON to this kind of NFTs path, to this kind of folder that I just created. And as you can see, I have here all the data for all the NFTs downloaded. Just by running the script, it downloaded it for me. So this is quite cool. So Python is a good skill. If you want, you can learn it, and it's very useful to automate this kind of task. And you can see that I stopped in the middle because it takes time, because imagine it downloads a lot of data from the net, and I found another thing and I saw that these JSONs are not valuable for me anymore. So I stopped the script, but this is a cool thing that I did, and I wanted to share it with you through the process. And now I thought, all right, where the hidden answer might be. And I thought, all right, maybe it could be in the JSON data itself. So maybe there is one of the NFTs that the description would be different. Maybe there will be one of the NFTs that the attributes number, here we have 1, 2, 3, 4, 5, 6, 7 attributes. Maybe there is another NFT that has 8 attributes or 6 attributes. Another thing that I thought is maybe there will be an NFT that is part of different collection. So this is the collection ID. Maybe I will find an NFT that the URL is a bit different, but it cannot happen. So it doesn't really matter. And so what I did, I wrote another script. And this is the other script that I wrote that actually, how it's called, filter NFTs. So this script is actually what it does. It opens the JSON file that I already uploaded, that I already downloaded, and it searches. This is the base description, this is the base collection ID, and it searches for abnormal behavior for an NFT that does not match this kind of description, does not match this kind of collection ID. And you can see here that I'm running in a for loop, and not all the NFTs, all the ones that has been downloaded. I was very anxious. I was sitting in a cafe, you know, like very into the computer, waiting for the JSONs to be downloaded, to be fast. And then I ran through all the JSONs, got the image and downloaded it. And now I try to see maybe the description, if it's not the same, the base description, then I want to print a message that I found an NFT that his description does not match all the description of the other ones, because they're supposed to be the same. If he has different number than 7 attributes, I want to know it, so I print it. And if you have a different collection ID, this part on the URL, on the image, then I want to know it. So this was actually the script that I made. And again, I could find nothing. I didn't find anything. I was very sad. And I thought, all right, the last place that I would look at would be the images themselves. But how the hell I'm gonna go through 10,000 images and analyzing them? Even in Python, it's complicated and it's hard. So I said, oh, okay, maybe it will be simpler. And then I remember that actually in IPFS, there is something that you can do, which is directory listing. So instead of opening here, instead of opening the image itself, you can actually go remove this kind of thing from the URL and then get kind of list of all the resources that have been uploaded to this kind of collection. So that's what I did. And you can see right here. So the first place I went is to the collection ID, to where all the resources of the JSON files are located. But yeah, right now it's not here. here it is. So you can see this is actually the directory listing of this kind of directory inside IPFS. And you can see here all the JSONs, and I went through all the JSONs. I wanted to find maybe something odd, and I couldn't find anything because it has from 0. So from PancakeSwap 0 to 1999, exactly 10,000 NFTs data of JSON format. Nothing interesting. Then I went to the images and look what I found. So I went to the directory of the images, and actually all the scripting, it wasn't for nothing, it was fun. But eventually, just by going to this kind of directory, you could find this MissingNO.png. And then I said, all right, that's it. I got it. You can see all the pictures, right? 0 to 1999, and then you have this kind of image. And if you open it, this is the image that you get. And I understand that I went to the next level, and now I'm on the next phase. I solved the previous challenge. I found the image. Now I need to download the image. So that's what I did. I saved the image itself, and it's already downloaded, but just let's download it again. And I open it. You know, I take a look at it, start to observe the image, start to see what it is, and maybe I can find something in the image itself. So I opened the image with my image preview app, and I zoomed in a little bit. Also, I tried to look for some kind of text right here, or maybe right here, you see here, and I couldn't find anything. Now the next phase, next pattern of thinking was, all right, so it's not in the colors, but it might be inside. So remember that we talked about steganography. So we will go first to the basic of steganography. So what I did, there is some kind of a program called strings. I will just move it from the downloads, the image, to this kind of directory, MissingNO to here, MissingNO.png, and we will move it here. So now we got it here. The image is in this directory, and I ran a program called strings. So strings is a program that goes through a file and extract all the patterns that match for a string, for a text. So I did strings, MissingNO, and MissingNO.strings. And now I throw all the output to a file called MissingNO.png.strings, and it will extract all the strings that we have in the image itself, because an image is a data. You can actually open it with a text editor. So if you go to where was it? It was, you know what, let's do like this, open dot. Okay, we go to VS Code, and this is the image, and you can actually open the image here as text. Now it's as picture because VS Code default for PNG file is showing the picture itself, but you can click here, reopen editor with, and then text editor, and now it will show you all the data. And this is a lot of gibberish, a lot of binary data that represent all the colors, all the pixels of the picture itself, and it's hard to find. But actually, if you scroll it here, you will find it here. You see, right here. This is something odd that does not, usually PNG pictures does not contain this kind of ASCII art, but in my case, I went for the easier way, and I just filter the strings. So this is the strings, this is the output of the strings commands, sorry. And now I removed all the binary data, and I only find for patterns of string, and now it's much easier to find because if you scroll down, you can find it very, very easily, you see, because here you can find it. So it's all string, 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 and then you have this kind of huge ASCII art of Pancake in the middle of everything. And I thought, all right, that's it, I got it. This is the next level, this is the next step. And now what should I do? And you can see like a big ASCII art of all this kind of huge pancake, and you have a sentence, you have a paragraph in the middle, and it doesn't look like, it looks like in the English letters, but you cannot read it. So I went to the end, and you can see no Easter eggs here, and I understand that it's reversed and it's opposite. So I copy it, I went to Google, and then I could reverse string online, some kind of tool that will reverse it back. And I pasted a string, reverse string, and now you can get it in a much more easier way, much more nice way. And I take it again to my VS Code, to my editor, went to the paragraph here. I already did it, but this is basically what the paragraph means. So no Easter eggs here, friend. I don't know what you think you're going to find, but you're mistaken. No giveaways, nothing weird. Definitely no pancakes. Just turn around and walk away. Equip a strong slab so that when the company board gets too sad, they go home to their obscure families. With Grace, the tall lady, will not slice the cake. Traffic begins rolling away. Right. No secret phrase here, no keys, of course. So if you're familiar with secret phrases and you see like equip, you see board, you see Grace, you see a lady, you understand that there should be somewhere inside this kind of text a seed phrase. A seed phrase is being assembled in 12 different words, not always different, it could be the same, that comes after another, and they also need to be in the same order. And by getting this seed phrase, you can assemble the private key to some kind of wallet. So I understood that the seed phrase is supposed to be somewhere here. But how the hell do I find 12 different words that I can assemble from them a MetaMask wallet and access this wallet, and maybe in this wallet there will be the next hint, next clue, or maybe the gift itself. And it was the next challenge now is to get to assemble those kind of 12 words, and it's not easy challenge, it's not easy task. So what I did, first you want to filter out all the words that cannot assemble a seed phrase. So I went to Google and I searched for seed phrase in order to find all the words that cannot be used in a seed phrase, because there is certain list of whitelist words that can be used. And I scroll down and you can read about seed phrase, what it is, BIP39. So this kind of protocol is kind of standard, and you can see an example of how a seed phrase look like. 12 word seed phrase. There are also variations of 15 words, 18 words, etc., etc. But 12 is the most common, the most popular that is being used. And you can see there are actually 2048 words. And these are the options, some kind of explanation, calculation. And I scroll down a little bit until I went to BIP 39 standards to see what kind of words, no, it wasn't here. To see what kind of words can assemble a seed phrase. Yeah, this one. BIP 39 word list. So I wanted to get a word list of all the whitelist of the words. I went to English, and this is the list. I click hero, and now you can see you have here 2048 words that using these words you can assemble a legitimate seed phrase. So I went to word list, I pasted it here. Now the next thing that I need to do is actually divide every word to a different line. So I use my magic addition skills in VS Code. So I'm going to replace space with \n, which represents a new line. And now automatically it's already divided to new lines. And I'm going to replace a dot with nothing because we don't want dots. And I'm going to replace a comma with nothing as well. All right, now we have the list, all the paragraph divided to a list of words, and now we have this kind of list of words that are legitimate seed phrase words, and now we need to do a slicing. And what a better way to do it rather than Python? You can use online tools, but I like Python, so I did this kind of scripts. And basically it goes through the paragraph and through the word list, and it actually goes and checks every words in this kind of par file. Every word checks if it exists in the word list. If it exists, it prints it out. If not, it's not. So this is the script to filter to find all the words that are matched. So I ran Python 3 and the script called find words. And there you go. Out of all the words that we have in the paragraph, these are only the words that can be used. So I make a new file, matched words.txt. And these are all the words that can be used in order to assemble a seed phrase. I also assume that's in the same order, because in order to change the order, it will be too many combinations and we need to do some kind of brute force attack, and it will be too complicated. It's already complicated. So out of 65 words, we filtered it out to 27 unique words. All right, this is still too much, and I couldn't. I tried many things, so I tried to narrow it even more down, and I thought, all right, the story starting to get weird. Let's go back. When this kind of paragraph starts, so I said I made only a short paragraph. Okay, I took only this section. I said, okay, maybe the seed phrase is not here because, and maybe all the connection words, you know, they needed to assemble some kind of story that makes sense. So maybe they are not part of the seed phrase, but you cannot know for sure. So I only took this kind of paragraph and I made a new file. I pasted it and I saved it as PancakeSwap.txt. And again, we're gonna create new lines, replacing space with new line, replace all, and replacing this with nothing, and replacing this with nothing. All right, now we have a short paragraph, only the second paragraph where the story starts sounding weird. Equip a strong slab, so what when, so it looks like they try to put the seed phrase inside here. And that's what I did. So I ran the script again, but this time on para short. Find words. What happened? It's not saved. And there you go. This is the matches word for the short, the second paragraph. So matches words short.txt. Now we have even less words. We have 17. So we narrowed down our search from 60 something words to 17 potential words. And now I started to understand what kind of words maybe they put it in the story so it will make sense. So I said maybe that, I removed date, I removed cake because what are the odds that they will generate a wallet and there will be cake inside? So maybe slice because it's sliced cake. Or I also try to go to every second row, strong slab. So maybe I picked only slab, not strong slab. Or if it's like slice the cake, so I pick only slice because it's still, I need to get it down to 12 words. And it was super hard, super hard. And I spent like 3 hours on it. I tried different combinations, different wallets. And by the way, how do you create a new wallet? So I created a new profile on Google Chrome, and I reinstalled here MetaMask. I installed MetaMask, so MetaMask extension. And after installing MetaMask, you can actually load an existing wallet by providing a seed phrase. All right. So I did add it to Chrome, and it will download the MetaMask. And then I tried every 12 words. So I took maybe these ones, and again I will replace. Now we need to replace the \n with a space, right? So I took this kind of 12 words. Once the extension will be installed, I will show you how it looks like. And I tried different combinations of seed phrases out from this kind of 17 words in order to get the answer, to get the wallet. So import wallet and no thanks. And I pasted here the seed phrase, invalid secrets phrase if you add another word. So you can see that it could be 12, 15, 18, 21. So I tried many combinations. I was frustrated and I tried a lot of things to remove, and actually it's not solvable because you have too many combinations. You need to run some kind of script to automate this task. If not, you cannot solve it. You will never be able to solve it. And that's why I think Chef Rabbit Doge, he posted many hints through the challenge, but eventually the last hint was crucial because without this hint, this challenge is not solvable. And the last hint was, I even managed to get access to a wallet that was empty. So these kind of combinations, if you add them together, and you can get a legitimate wallet. So you can see here, wait, it's not this one. Never mind, I managed to get access to an empty wallet and it was not the right wallet, but you have so many combinations that I even got a legitimate one. And eventually he posted this kind of hint. So this is the hint that actually without this hint, it's not solvable. So it basically tells you what are the first 5 words. So it's equip, slab, when, board, and what was this one? I cannot see it. Never mind. So let's copy, open image in new tab. and said. So these are the first 5 words. And once you have the first 5 words, it gets much easier, because now if we go to the short list, we know that the first one is, equip was not here because I needed to change it to a lowercase. Never mind. So you know it's equip, and you know it's not strong, right? Because the next one is slab, so you can remove strong. And then when is legitimate, so you can see that that is not part of the list, and you know that company is not part of the list, gets to said. Now we have 15, so we just need to remove 3 more words, and I thought that the word would be day because it's connection word, you know, and wheel and cake, and there you go. Once you got this, and you can get the wallet. So now I change the \n to space, and these are the 12 words that probably will get us access to the wallet. And there you go. Now you have a legitimate working seed phrase, and I did it very fast. Once I saw the tweet, I did it super fast, and you have to put a password, and there you go. And you get a password, and you got an access to a wallet, and this wallet, this is the address. You can go to bscscan in order to take a look at the address, and I got access to the wallet. Really, it was super fast. Right after he posted it, I got it because I was 3-4 hours stuck in this kind of assembling the seed phrase, and when he posted it, after like 1 minute, I got it, and I got access to the wallet. But unfortunately, when I got access to the wallet and I checked it on bscscan, I saw it was like 15 seconds. So 15 seconds before I got access to the wallet, someone was on the same steps, and he was faster than me, and he got the PancakeSwap NFT. Once I got access to the wallet, I saw that actually there is BNB here. We will have to add the bscscan, the Binance Merchant. So I saw there was BNB and cake in the wallet. I didn't take it because I was so sad. I was like, oh my God, it's not fair. I solved it 3 hours ago, and without its end, it's not solvable. So, but it's okay. It's the first Easter egg. I love it. Thank you so much, Chef Rabbit Doge, PancakeSwap team, for making this kind of fun seed phrase. And I hope, I know for sure that next time it will be perfect, because this time, I think that next time you should like put a bit less hints, because I felt that I'm going forward and I find something, and 2 hours later I see a hint. I'm like, no, don't tell them, it's a competition, don't tell them, don't help them. I want to be the first one who finds it. And the second thing that I would improve is actually make sure that it's solvable, because it wouldn't be solvable without this kind of this last hint of the 5 words. And yeah, that's how you solve this challenge. It's a very cool challenge. I super enjoyed it. It reminded me the old good days where I used to do a lot of CTF challenges of cybersecurity, and it was super fun. So thank you so much again. By the way, this is the cake. So when I got into the wallet, there was some BNB. I didn't touch it because I was so shocked that someone took the NFT, the PancakeSwap NFT before me, that I didn't care about the BNB, and also there was some cake inside. But that's it. This is the walkthrough. This is the solution of this super cool Easter egg CTF challenge by PancakeSwap. Thank you so much for watching. Thank you so much for watching this challenge. I had so much fun, and I learned new stuff about IPFS, about seed phrases. So thank you. Please consider subscribing to my channel and smashing the like button for the YouTube algorithm. I have so many other PancakeSwap videos, educational videos. Check them out in the description below, in my channel, in my playlist. Thank you so much once again, and I will see you in the next guide. Bye bye.